Alright, today we're going to be learning about the quadratic formula, which is this formula right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Before we can use the quadratic formula, we need to make sure it's in standard form, meaning that we have it, the x squared term, the x term, the constant term, and then it's equal to 0. This formula will give us two solutions. Why does it have two solutions? Two solutions come from the plus and the minus here. We'll have our answer where negative b is added to the square root, and we'll have it when negative b is subtracted with this square root. Next part is the discriminant. This tells us what kind of roots that our quadratic will have, and it is found underneath the radical. If our b squared minus 4ac is greater than 0, that means we're taking the square root of a positive number. That means we're going to have real roots. We're going to have two real roots. More specifically, though, if it is a perfect square, we're going to have two rational roots. And if it's not a perfect square, then we're going to have two irrational roots. If our discriminant is equal to 0, that means we're taking the square root of 0. If we add 0, or if we subtract 0, we get the same number. So that means this one is going to have one rational root. And then finally, if our discriminant is less than 0, that means we're taking the square root of a negative number, which means we're going to have two complex roots. So now let's look at some examples. Solve for x if x squared plus 6x plus 14 equals 0. So in this equation, we need to find a, b, and c. We can start finding a, b, and c right away because it's already equal to 0. A is the 1 that's invisible in front of the x squared. B is the positive 6 that's in front of the x, and c is our 14 on the end. The first thing we're going to find is the discriminant, which was b squared minus 4ac, which would be 6 squared minus 4 times 1 times 14. We're going to type this all at once into our calculators, and it will give you negative 20. Since it's a negative number, we know our final answer should be two complex roots. And we're going to use that to help us check our answer at the end. So we're going to plug in the rest of the formula. So we know x equals negative b would be negative 6 plus or minus the square root. We already figured out that this whole thing equals negative 20 over 2 times 1. So the next thing we need to do is simplify the square root of negative 20 since 20 is not a perfect square. So we'd have negative 1, take care of the negative part, and then what perfect square divides into 20? That would be 4, and 4 times 5 gives us 20. So we're going to square root all of those. So x equals negative 6 plus or minus square root of negative 1 is I. Square root of 4 is 2. Square root of 5 is a decimal, so we're going to leave it as square root of 5 over 2 times 1 is 2. Then our last step is to check and see if any of this can be simplified. If this number and this number are divisible by this number, then we can simplify. which in this case they are. So x equals -3 plus or minus 2 divided by 2 is 1, so we don't have to write it, I square roots of 5. Now, what type of answers did we say from our discriminant we were going to have? Said we were going to have 2 complex roots. I and real means it's complex. So that's our final answer. All right, let's take a look at another one. Do you notice something that we need to change about this equation before we can get started? Hopefully you said that it's not equal to 0, so we're going to subtract 2, and we end up with 3x squared plus x minus 2 equals 0. So we know a is 3, b is 1, and c is -2. So the first thing we're going to find is our discriminant. So 1 squared minus 4 times 3 times -2. When we simplify all that, we get 25. So since 25 is a positive number, we know we're going to have real roots. And since it's a perfect square, we know we're going to have 2 rational roots. So let's keep plugging things in and see what we get. X equals -b would be -1 plus or minus the square root of our discriminant, which was 25, over 2 times a. So let's start simplifying. -1 plus or minus the square root of 25 is 5 over 2 times 3 is 6. So since we have eliminated the square root and we don't have any imaginary numbers in this, we can simplify more. So I'm going to break it up into 2 statements. -1 plus 5 over 6 and -1 minus 5 over 6. So let's simplify these. -1 plus 5 is 4 over 6. -1 minus 5 is -6 over 6. So that means x equals, when we simplify the first one, we get 2/3. And when we simplify the second one, we get -1. Are both of these rational numbers? Yes, they are. So our roots matched up with what our discriminant told us they were going to be. All right, so one more example, and then we're going to do a word problem. We're all set to start with this one because it already equals 0. So a equals 2, b equals -6, and c equals -1. So let's find our discriminant, -b squared. Make sure you're putting your b term in parentheses when you square it, because this one happens to be a negative, so we have to make sure we put the negative in parentheses when we square it on the calculator. -4 times a times c. And this gives us 44. It's positive, so we know the roots are going to be real, but because it's not a perfect square, we know we're going to have 2 irrational roots. So let's solve. X equals -b, so -6 would become +6, plus or minus the square root of our discriminant, which was 44, divided by 2 times a. So let's simplify. What's the biggest perfect square that goes into 44? That would be 4 times 11. So x equals 6 plus or minus the square root of 4 is 2, and the square root of 11 is a decimal, so we'll leave it as the square root of 11 over 4. Now, what do you notice about all 3 numbers that are outside our radicals? All 3 of them are divisible by 2, so we're going to simplify. If only 2 of them were divisible by something, you can't simplify. It's all of the numbers or none of them. So if we simplify, x equals 3 plus or minus the square root of 11 over 2. All right, now time for our word problem. The equation for an object's height, s, at time t seconds after a launch is given by this equation. S of t equals negative 4t squared plus 97t plus 75. When does the object strike the ground? You should know that since it's got a square in it, we know it's going to be a quadratic, and since it's negative, it's going to be a quadratic that faces down. So an object is launched up into the air, and then eventually gravity brings it back down. And we want to know how long it takes, or at what time it strikes the ground. When it's on the ground, what is that object's height? When it's on the ground, it's 0 feet off the ground, so its height is 0. So 0 equals negative t squared plus 97t plus 75. So now we know A is negative 4, B is 97, and C is 75. So let's find our discriminant. 97 squared minus 4 times A times C, and that gives us 10,609. So x equals, actually, since we're given t in our equation, we're going to use t equals negative b plus or minus the square root of our discriminant, all divided by 2 times a. Now, before you try and simplify this square root, especially because it's a really big number, type the square root of 10,609 in your calculator. Hopefully you realized that that is a perfect square. So negative 97 plus or minus 103 over negative 16. So let's split up our equations so we can find our final answers. Negative 97 plus 103 over negative 16, and negative 97 minus 103 over negative 16. I'm sorry, I messed up the denominator. Our a value was 4, not 8. All right, so negative 97 plus 103 divided by 8 gives us negative 0.75, and negative 97 minus 103 divided by negative 8 gives us 25. Which one of these answers makes sense for when the object is going to strike the ground? Hopefully you said 25 because we're talking about time, and time is positive because we can't go back in time yet. So we know that the object will strike the ground after 25 seconds. That's all for today. Thanks for watching. See you in class.